All right, this lesson is about lines and angles. Different kind of lines, different kind of angles. The first thing we're going to look at is parallel and skew lines. So this idea of a box we looked at in Unit 1. And we had a box and we were looking at parallel planes. We were looking at lines that intersect. And in this case, what we're going to look at are lines that intersect. We could also look at lines that are parallel to a plane. And we know what parallel means, non-intersecting, right? Non-intersecting lines, non-intersecting planes. Now, have you ever heard of skew? Skew lines. Skew is like in 1980, back in the 80s, back when I was around your age, we had a song, Mr. Roboto. And one thing we did to dance to that song, Miss Jurek, do we know?
You want me to demonstrate?
We would do the robot. That's right, everyone. And these arms, everyone go ahead, do the robot. Come on. These arms are skew lines. So, we've got skew lines in 3D. And if we were to highlight some skew lines, let's look at line DA and see of another line that's skew to it. BF is definitely skew. What else? GF is. Wait, GF is not skew because it is parallel to AD. Yeah, so we can't have that. What about, you said CG? That works. BF works. What about HC? And I know that that goes through. Would that be skew? Actually, from this perspective, they look parallel. But if you made this 3D, would they be skew? It would. It would. So that is unique. That's what skew is. Parallel planes, let's look at that. Those are definitely planes that do not intersect. So parallel planes are planes that do not intersect. Such as you got the top, bottom, the two sides, and the front, back. Correct? Okay, those are our terms. A line and a plane that do not intersect are parallel. Segments and rays can also be parallel or skew. Lines are parallel if they lie in parallel lines, and skew if they lie in skew lines. So, right here, what I would like you to do is to chit-chat with your group and figure out the answers to these. Go for it. Segments parallel to AB, what do we have?
DC, EF, and H.
Okay, now when you're writing DC,
You put a line on top.
you do, indeed. And also HG works. What else?
EF.
EF works. Nice. Skew to CD. So now we're talking in terms of skew. Oh, okay. Now CD is here. What would be skew? Go ahead.
BH, FG, and BF.
B, did you say BH?
BF.
Also works. What about AE? What about FG? EH? Okay, any others? Okay, parallel planes. Let's look at planes parallel. Go like this with your arms. Did you do top, bottom, the two sides, or front, back? So you did top, bottom, sides?
Thank you.
All right, well, if you do top, bottom, it'd be this guy. Now, did you name the plane with 3 capital letters right next to each other, no line above it? So this would be plane BAD and plane parallel to that would be FEH. Now, could I have named the top plane CBA? Sure. DCB? Sure. The bottom plane could be GHE. Multiple ways to name planes. What are 2 segments parallel to plane CGF? So let's look at CGF. CGF is this back plane here. Now, segments parallel to a plane. If you think in terms of this wall, a vertical line like my arm is parallel to this plane. Horizontal is also parallel. What if I have it at a slant?
Still parallel.
Still parallel. So that is probably the most confusing thing to students. So we've got AE would be parallel. What else? AH works. And that's at a slant, but that is also parallel to that plane. What else? Uh-huh. ED works. EH. And we've got all these lines, and they could be at a slant. They don't have to be vertical or horizontal, parallel to a plane. Questions on that? Okay, next page. Transversal is a line that transverses, cuts through two other lines. Now, more often than not, we see these two other lines as parallel, but you don't have to. Interior angles are these angles that are found inside the two lines. Exterior angles are those angles found outside the two lines. So you got interior and you got exterior. The second thing that you have is, see the transversal? You can talk in terms of the same side of the transversal, or you could say it's on alternate sides, or on the other side of the transversal. So we can talk in terms of, we can name angles in terms of how they relate to the two lines and how they relate to the transversal. Okay? And here are the terms that we're going to learn. Alternate interior angles. We got the two lines L and M. We've got the transversal N. Alternate interior means the ones inside that alternate around the transversal. So 4 and 5. What else? Name another set of alternate interior angles. Angles 3 and angle 8. Same side interior means same side of the transversal and inside the two lines. So we could say 3 and angles 3 and angle 5, and we can say angles 4 and angle 8. Corresponding means in the same position as. So notice corresponding is the only one that's not saying same side or alternating or interior or exterior, because corresponding means in the same position. If I took one intersection, put it on top of the other one, these angles would be at the exact same place. So angles 1 and 8. If I say angle 2, what is its corresponding angle? If I say angle 3, what's its corresponding angle? And angle 4's corresponding. Good. Okay, alternate exterior. 1 and then 2. Now, we could also have same side exterior, and that means on the same side of the transversal outside. I just don't have it on here, but you get the idea. Parallel lines cut by transversals. So, sometimes the lines are parallel. And so if lines are parallel, you will see extra arrows on the ends. See those two yellow arrows? That indicates those two lines are now parallel. And when lines are parallel, we can start to say things. The relationship is the vocabulary that you guys have learned. The relationship would be between 2 and 6. They are corresponding. The result of that relationship is when lines are parallel, corresponding angles are congruent. What we have here is 1 and 3. These guys are vertical angles, right? When you're looking at one intersection, you use vertical and linear pair. 1 and 4 are a linear pair, right? But when I'm analyzing 1 and 5, this relationship, they are corresponding because they're in the same position as. The the result of that relationship is corresponding angles are congruent when lines are parallel. What about 4 and 6? How do those relate? They're alternate interior angles, and the result of that is they're congruent when lines are parallel. What about 7 and 2? They can't be linear pair because they don't share a vertex, but they're same side exterior, and the result is they are supplementary. They add up to be 180. Okay? So do you see that? Do you start to see that relationship? Okay. Then let's go to this next one. Answer 1 and 2 with your group. Go. So one thing that might be tricky about this problem is these two lines, listen up, are not parallel. But they don't have to be parallel. And if you don't have parallel lines, all you have is the relationship. You don't have the result. So for example, 2 and 4 are still corresponding. But because lines are not parallel, you don't have that they're congruent. You see that? We can still call them corresponding, but they're not congruent because lines aren't parallel. So what would be a pair of alternate interior angles, you guys? 2 and 6. Identify 3 pairs of corresponding angles. Angle 1 and angle 3. Angle 8 and 6. Angle 7 and 5. You got it. Nicely done. Let's go next page. Royal Ontario Museum in Toronto, Canada. This reminds me a lot of the Rock and Roll Hall of Fame in Cleveland because of all the different shapes that you get on the outside. Let's identify the relationships here. I'm going to go ahead, answer these, put the terms down, check with your group, and then we'll go over. 2 and 4, what kind of angles are these? Alternate interior angles. 1 and 3, corresponding. What questions do you have?